I am G RAJALAKSHMI, Assistant Professor, Department of EIE, Satyabama Institute of Science and Technology, deemed to be University, Chennai. Now I am going to discuss the silicon control rectifier for you. Silicon control rectifier is a semiconductor switching device used as a control switch for rectification, power regulation and inversion. And before getting into the topic, let me tell you why we have chosen silicon instead of germanium. Comparatively, the silicon has got less leakage current, and the other thing is that germanium crystals are easily destroyed at higher temperatures, and then the peak inverse voltage of silicons are higher than the germanium semiconductors. This is the reason why we go for silicon controlled rectifier, and as the name implies, it is mainly used for a rectification action. Now let me tell you the construction of the SCR. If you see, you can imagine the SCR as two transistors connected back to back, or else you can imagine as see here PN, a diode is here, another PN diode is here, as if two diodes connected back to back. So you can imagine two-way, two transistors connected back to back and diodes connected back to back. One transistor is PNP transistor and the another transistor is NPN transistors. If you look at the terminals of SCR, it has got anode, which is a P-type material, cathode, which is an N-type material, and you have a gate formed by a P-type material. And it has got three junctions, namely J1, J2, J3. Now this is the symbol of the SCR. It is more or less like a diode, and extra terminal is the gate. It resembles as a diode, but still you have an extra terminal as a gate. And then if you look into the equivalent circuit of SCR, as I told you earlier, we have imagined that there are two transistors connected back to back. It is a PNP transistor which has got emitter, base and collector. And this is the NPN transistor where emitter, base and collector are there. If you see, transistor 1, the base, and transistor 2, collector is connected. Here if you see, the collector of transistor 1 and base of transistor 2 are connected. It is all equivalent circuit under imagination. Now I will tell you the working of SCR in three different modes. One is forward blocking mode, the next one is reverse blocking mode, and the other one is forward conducting mode. Yes. Now the anode is connected to the positive terminal and cathode is connected to the negative terminal, which says anode is positive with respect to the cathode. Now the gate is not supplied with any voltage, as anode is a P-type material which is connected to the positive terminal and cathode is an N-type material connected to the negative terminal. Junction J1 and junction J3 are forward biased. Now let me tell you, junction J1 and junction J3 are forward biased, and junction J2 is reverse biased. So since the junction J2 is reverse biased, there will not be any flow of current, but still you can find a leakage current due to the minority charge carriers. Look at the characteristics curve, it is plotted between forward voltage and forward current. This curve you can find here, there is a less amount of current flowing here. See, this is a very less current because of the leakage. This is the forward blocking mode. Whatever I told you is a forward blocking mode. Now we have to turn on the SCR, but since junction J1 and J3 are forward biased and junction J2 is reverse biased, we get only very less current. Still the SCR is not switched on. To trigger the SCR, we have to increase the anode to cathode voltage. Still further, if you increase the anode to cathode voltage to a larger value, you can find the breakover voltage VBO occurs. This is called VBO, which is a breakover voltage. The voltage at which the SCR starts conducting when the gate is open, that is called breakover voltage. Now you can find when you increase the voltage beyond the limit, you can find this. Now it is in the on state. Okay. Next condition is when you are going to connect a negative terminal here and a positive terminal here. So at this instant J1 and J3 are reverse biased and J2 is forward biased. Since J1 and J3 are reverse biased, we know that under reverse bias condition you will not get any conduction. You have connected a negative terminal to p-type material and a positive terminal to the cathode. Since we have connected anode to the negative terminal and cathode to the positive terminal, now junction J1 and J3 are reverse biased. Junction J2 is forward bias. So at this condition we know that they will not be getting any conduction. But still further, if you increase the voltage, junction will break down. That is why you can find when you increase the reverse voltage, the avalanche breakdown happens and then it starts conducting. Now it behaves like a diode, ordinary. If you find the characteristics, it behaves like an ordinary diode. Here the avalanche breakdown takes place and then it starts conducting. Now this is a reverse blocking mode, that is over. Next is forward conducting mode. So in the forward conducting mode, what we are going to do is we are going to connect a positive terminal to the gate, and here this is positive and this is negative. This is positive and negative. So we are going to apply a small gate voltage, that is the gate will be positive with respect to the cathode. So now what will happen is if you apply a small voltage to the gate, now we can find the SCR starts conducting. That is the charge carriers will start moving. From n-type material, the electrons will move towards the p-type material and the holes will tend to move from p-type material to n-type material. Now if you give a small gate voltage, the SCR will be switched on. The second case is that once the SCR starts conducting, the gate will lose all its control. You cannot bring back the SCR to off condition. The only way to switch off the SCR or turn to off condition is that you have to decrease the anode to cathode voltage. So it is possible to switch or trigger the SCR by providing a small positive voltage to the gate. And once SCR starts conducting, the gate will lose all its control. You cannot bring back the SCR to off condition. The only way to bring it to off condition is that you have to reduce the input voltage between anode to cathode. I think this topic would be useful for you. I will meet you with some other video lecture and some other time. Thank you.